Thank you. Welcome everyone to our the Priva Academy live training session. My name is Henry Van Gameren, and I'm responsible for marketing here in North America, or for the Americas. Thanks for joining us today. And of course, Ron Huizinga, who's going to be our presenter for today. He's one of our senior technicians here at Priva. He's been with us over 30 years, and he's quite the knowledge center. So we hope that this session is going to be quite informative for you. We do encourage you to ask questions throughout the session, and you can do that just in the chat. Please keep your microphones muted if you can, just to minimize any background noise. And of course, following the session, we'd love to hear any suggestions that you might have for future sessions, because we plan, of course, to keep this program running next year as well. If there are any topics that you have missed or you can't stay for the whole session today, we always have a recording available for you on the Priva Academy. So today we're going to be covering energy management and heat management, and Ron's going to provide you with somewhat of a comprehensive overview and exploration of some of the essential components on boiler settings and measurements. You're going to learn about advanced strategies for effective heat management, buffer calculations, heat buffer, and boiler CO2 control. So again, please ask your questions. We will interrupt Ron with the questions because we'd like to keep it the questions timed to what he's presenting at the time, and therefore we can stop Ron. I will ask him the questions, and he'll be able to answer it as he's presenting. So I'd like to hand the microphone over to Ron. I'd like to ask you again to keep your microphones muted, just to minimize any noise. And again, if you please put your questions in the chat, and we'll get to those, hopefully all of them, because we do have an extensive audience today. We've got over 25 guests. So we're hoping that we're going to get some great questions for you. So Ron, please, the microphone is yours now.
Thanks, Henry. Like Henry said, my name is Ron, and I've worked with Priva for many years. I'm located in Niagara, close to between Toronto and Niagara Falls. That's where I'm located right now. And I do travel for Priva, so I am on the job sites many times, traveling around to different customers. So yeah, today, like Henry said, I'm going to do energy management, heat management today. And so this is I got a slideshow, and I have a demo system that was running that I'm going to show some of the settings on the actual pages of Priva Office. So we're going to talk about boilers, heat management, heat buffers, heat buffer controls, and the CO2 management. So basically, I see a number of names here that I recognize, that are people that are experienced with the system, and there's names here that I don't recognize, that are probably are very new to the system, maybe don't even have the boilers on the Priva yet. So hopefully I can be general enough to cover enough details for everybody to get some information out of this presentation. So here we have an overview of a very common boiler buffer system, heating system. So typically most people will have a natural gas boiler, and the natural gas boiler will run and heat. So if you don't have a buffer tank, it'll heat directly into the heat manifold, which will then have transport lines or mixing valve groups that go off to the greenhouse. And but again, many customers have a buffer tank, so the boiler will actually fill the buffer tank, and then later on, the buffer tank will supply the heat to the greenhouse. So the boiler control is started. So typically in our controls, if you have a buffer tank, the boiler is controlled by filling the buffer tank. So it doesn't really look at the greenhouse demand. The greenhouse basically looks at how full or empty the buffer tank is, and to fill up to what you need. So I go to So here's a picture of our demo system with 2 boilers, very similar as the first page, and a buffer tank. And these systems are called open buffer. Basically, that means that between the buffer in the heat manifold over here on the right side there is no valves. There's no pumps, no valves. So basically, when the greenhouse needs heat, and if the boilers are not supplying the heat, then the heat will come out directly out of the tank. So that I know, and then the return from the greenhouse will be going into the blue line here and be coming to the bottom of the tank. So basically, the return of the tank is basically determined, water temperature of the tank is basically determined by the return water of the greenhouse. So to go through some settings. So basically, this is our boiler page that people will put the temperature settings in. And actually, I think I'll just like to start off with, basically, if you have a well-running system, if everything's kind of working properly, there's actually not that many settings to change in the Priva system. Basically, I think sometimes I give as an overview as the only settings you have to change is in your heat management on line 8, your minimum fill percentage of the buffer tank. So basically, this is how much heat you want to keep in your buffer tank as basically as a safety in case it gets cold outside. So in the summertime, of course, this number could be very small, like 10% of the buffer tank is hot. Maybe at the spring and the fall, make this 20% or 20-30%. And in the wintertime, make it 40%, that you want to keep at least 40% of heat in the tank. So basically, I think the rest of the settings you could probably leave as they are, and it would work, and the system would work actually fairly good all year round. You wouldn't have to make any other settings anywhere in the system. Of course, growers like to play around and fine tune what they want, but this is kind of a simplified version of settings, that the only settings you would actually need to change. So when I talk about heat in the buffer tank, so basically this tank, we put about normally about 10 or 11 sensors in the buffer tank from top to bottom. And basically, as the boilers run and fill the top of the tank, then basically they say the outgoing temperature of the boilers is, say, 90 degrees Celsius. For this presentation, I'm going to talk in Celsius. I know some of you guys are probably from the US. So the 90 Celsius, which is about maybe 190 Fahrenheit. So the 90 Celsius will fill the tank, and we'll push the water down, the cold water in the bottom of the tank, then we'll come back into the boiler, be heated up by the boiler, and it'll make a loop like this. So we'll keep filling layers of 90 degrees. So basically, if all the layers are filled up with 90 degrees, then that buffer tank is considered 100% full of heat. If all the tank is completely empty, which means it has all the return water from the greenhouse through all the sensors, then that basically determines it's empty. If the tank has 5 layers of 90-degree water, and the rest, the bottom of this tank is the return from the greenhouse, then it would be 5 out of 10 would be 50%. The tank would be 50% full of heat. Hopefully that's clear to people. There's 2 different levels that we talk in the tank. One is the heat level. So this is what we're going to talk about majority of today, is just how much heat is in the tank. There's another level in the tank, and that is water level. So there is 2 different systems out there. There's the systems with the I think it's like a nitrogen layer on top of the tank, which a pressure tank, and that controls the water level and the pressure in the system. And then there's the system that there's no nitrogen layer on the top of the tank, and basically there's just an open air to the outside, and basically in there we put a level pressure sensor in those tanks, so you see how much water the water level is in the tank. And basically the reason for that is if you have a leak in the greenhouse or a leak somewhere and the tank is dropping in water, then we can give an alarm to say the water levels dropped too low, you must have something wrong, and to give you an alarm to say you better be careful that you don't have a leak somewhere. So basically you can have two alarms, multiple alarms, but let's say two alarms. One is water low water level. So that means if it should be 100% full of water all the time. But if it drops a little bit, we can give an alarm. And of course, we have another water level, which is that you have a certain amount of heat in the tank all the time. And that's if that goes below a certain percentage, we'll give there's not enough heat in the tank. So back to our boiler settings. So basically we have max temperature. So that should be set roughly around that temperature, 96 degrees. It can be different temperatures, but it's can't be above 100, of course, because that's boiling. The important point of this temperature is that it can't be higher than the thermostat in the boiler, because the thermostat of the boiler can override the Priva controls. So the thermostat is higher priority to run the system than ours. So basically that 96 has to be lower than whatever the thermostat is set to. So if this is set at 96, you just set the thermostat to, let's say, 98 or 99 or something like that. The minimum boiler temperature, so that is when the boiler is not in use. So typically on a system, of course, the majority of the systems, if you're using a system like this, and we have a picture like this too, with 3 boilers. So basically the boilers, ideally, you want to run your boilers, most of the boilers will have the CO2 extraction from the exhaust, and the CO2 will have fans then that'll blow the CO2 into the greenhouse. And let me see if I have a picture of that. Here's an example. I took a screen capture from a customer. So basically this has 4 boilers, and the exhaust of the 4 boilers is linked together to CO2 fans. And then the CO2 fans will turn on and blow to the CO2, the exhaust to the greenhouse. So basically, of course, your plants only need CO2 during the day. So from your CO2 start time to your CO2 stop time is basically when you would want to run your boilers. And then of course so in many cases, a customer with a buffer tank, the boilers will start up in the morning when the CO2 starts, then run all day long. And then at the end of the day, they shut off, and then they don't run all night long. So that is a perfect scenario if you have a nice balance of heat demand in the greenhouse compared to how much heat you are supplying from your boilers. So then, so basically then, if you don't have a buffer tank, of course, your boilers will run for a while to supply heat to the greenhouse and to give your CO2. But once the greenhouse doesn't need heat anymore, if the sun comes out, then of course the boilers will overheat and shut off, and you will get no more CO2. So that's the whole idea of the buffer tank, so that the buffer tank can be filled up during the day and then emptied at night.
Ron, we just got a question here.
Sure.
It says here, what does it mean on the I300 for rows 7 to 8?
Rows 7 to 8, or 6 to 7. So 6 to 8. Yeah. Okay.
Yeah.
I was going to get to that in a little bit later, but we can talk about it now since we're talking about filling the buffer. So basically, if you're driving your boiler mainly for CO2, then I would say then you want to fill it up during the day. That's your main target. So you want to make this period your CO2 start time roughly, and you want to make this period your end of your CO2 stop time. So let's say your CO2 stops at 6:30 or 4:30 in the afternoon, and this starts at 8:30 in the morning. And then we use the up arrow, which means it follows sunrise. and this is the sun down arrow, so it follows sunset. So basically we're saying here that 100%, the tank is allowed to be filled up to 100% full of heat. So all the sensors can get up to 90 degrees Celsius. And then basically here we're saying that during the day period, this period 1, which is our day period for the CO2, the tank is allowed to get to 100%. Our desired fill is allowed to get to 100% full of heat during the day. But at night, we have no desired end fill percentage. There's no basically, this line 7 is desired for CO2 or desired for a forced storage, which I haven't talked about yet, but I'll get to that. So basically that 100% means that we're allowing that boiler to fill up, with a buffer tank to fill up to 100% for CO2. And of course, we don't need CO2 at night. So that means that the desired is 0% for the nighttime. And then this is our minimum that we want to keep in there. That's our safety margin that I started talking about, which might be the only setting you actually change seasonally.
Okay,
So
thanks, Ron. Sorry, the number on 7, that the /, what does that mean compared to, let's say, why is that different? What is that for?
I was just going to mention that, and that's
Okay.
this basically that means it's a ramp. So it's basically going to ramp from the start time to the end time to this from up to 100%. Basically, that means that you're filling your buffer tank at a continual rate from the start time to the end time, and not going at 100% full speed of all your boilers, and then you fill your buffer tank up by lunchtime, and then you have no room for CO2 in the afternoon. So basically, you'd want that slant there, so you'd actually ramp the boilers from the start time to the end time.
Okay, thank you, Ron.
You're welcome. So I was starting to talk about the boilers, and in I310 here, the minimum boiler temperature. So basically, once it hits the end of the day and the boiler is not needed for CO2 anymore, and maybe the buffer tank is filled up enough for heat, it's not needed to heat, then basically it's going to shut off. And basically what it'll do then is it'll slowly cool down. And like we're saying, this boiler is going to be running about 90 degrees between the min and max. Because if it goes over the max, it's going to shut off. And so when it's going to go, if something does go wrong, so let's say then eventually it's going to cool down to 70 degrees. So when it goes below 70, it's going to turn on to keep up its minimum temperature. So basically these boilers don't like to be cold. Most boilers, there's a few boilers out there that are condensing boilers, but most of the boilers don't like to be cold. It's not good for the boiler. So basically we want to keep at least 70 degrees. I think the number is actually like about 62 or Celsius, where if it goes below that, you can get condensation in the boiler and it's bad for the boiler. So usually we make a minimum here of about 70. And so as soon as it goes below 70, the boiler will run. And then we make an ongoing temperature of 3 degrees. So when it goes below 70, it'll turn on. And when it goes 70 plus 3 degrees to 73 up to 74, then the boiler will shut off. So basically then maybe it takes, it depends how well insulated your boiler is and how good the isolation valve that closes off the boiler. The isolation valve being the valve right here. So normally when this boiler is not needed, there's a valve here. Can everybody see my circle, my mouse turning the circle?
We see your mouse moving around it, yes.
Okay, good. So then basically when that valve closes, basically that boiler will cool down. And sometimes it takes 6 hours or so to cool down from 90 down to 70. It depends on how well insulated that boiler is, and as long as that valve here is not leaking. And then once it gets down to 70, like I said, it'll go up to 73, 74, shut off. And then it might take a couple of hours then to be off again and go slow down, cool down to 69, turn back on again and go back and forth. So then it'll do that on and off until the morning, until maybe it's needed to fill the buffer tank to our minimum percentage, or the CO2 will start in the morning again and we'll start the boiler up again. So the next setting down here is condensation temperature. And like we were saying in the these boilers, if they get cold, basically it's not good for the boiler. So basically if it goes, and we don't always make this 62 degrees like you need, because what happens is this actually works in a range between this temperature and this temperature. So as the temperature drops below 70 on this boiler down to 55, it'll actually then start saying I'm too cold, and it'll start, and if it's linked a certain way, it'll actually start closing mixing valves in the greenhouse. This is not normally an issue for a system with a buffer tank. So a system with a buffer tank, basically what happens if that boiler temperature goes too low, this valve will close, and it'll means that it isolates itself from the system, and then it doesn't close the mixing valves in the greenhouse. But if you don't have a buffer tank and you have that system set up, then basically with the this boiler, if it drops in temperature, then you still need heat in the greenhouse. So a boiler, basically that valve will stay open and it'll heat the greenhouse, but that that off-take mixing valve, that's what it's there's a calculation here, off-take limitation. So how much heat you can take off the boiler, that number will increase. And when it goes to 100%, it's actually closing all the mixing valves in the greenhouse. So it's not a very common situation since most people have buffer tanks. But if you do have a boiler that is not keeping up the temperature, then this is a way to help protect that boiler. So the offset, again, this is only used if you're, actually, let me go back to this return temperature for a second, because I like to explain that basically this pump here is a pump that pumps the water through the boiler. And then this pump pumps the water around from the hot side of the boiler. So we have 90 degrees coming out and it's pumping the water back here. And then we have this water coming out of the bottom of the buffer tank or the greenhouse. Let's say it's coming back as, say, 40 degrees Celsius. So that 40 is mixing with this 90 degrees coming back here. So basically, if that boiler gets too cold, well, the first thing that will happen is this pump will shut off. So that means this 90-degree water coming out, or this colder water coming out of the boiler will loop around like this, and it'll just loop around like this and keep itself warm. So normally in a system like this, with a boiler loop pump like that, the boiler shouldn't actually get too cold unless something goes wrong, like this pump fails. So we have an offset temperature here, and the offset temperature is, normally if you have multiple boilers, then you might want to have an offset temperature there. This is multiple boilers with no buffer tank. So you can say, okay, my greenhouse needs, the warmest mixing valve in the greenhouse needs 75 degrees Celsius. So I want to keep the boiler running 5 degrees warmer than that at 80 degrees Celsius. So just an offset on what the demand is from the greenhouse. But basically, if you have a buffer system, then we're basically that fill circuit, and I call this pump here fill circuit, because basically that pump pumps the water through the boiler into the tank and fills the tank up with water. So we call this a fill circuit. So then basically that fill circuit is going to adjust and try to target 90 degrees all the time to fill the buffer tank.
Ron, just have a question here. What would be the name of that pump? And then follow up with that is the recirculation pump. I guess the previous screen.
We always call this the fill pump on the system. So a frequency drive, it has an arrow through it in the drawing. It has a frequency, means it has a frequency drive on it. So normally this pump always has a frequency drive. There is different designs here. So this can be sometimes called the boiler loop pump or shunt pump. So there's different names people call this pump, but basically it's a boiler loop pump. It pumps it from the hot side of the boiler to the return side. And different engineers' drawings, I see it called different names. But basically, and also there's different designs here, because this what I'm showing here is a mixing valve, no mixing valve in the design here, but sometimes there's a mixing valve in here. So there's actually a three-way mixing valve that's also dividing up the water. Then there's only one pump and a mixing valve. And then there's, let me see if that other drawing had that. Oh, this drawing's the same. So then there's, yeah, so typically there's three different designs. This is the most common design with a mixing valve, the no mixing valve and variable speed pump. Lately, the last couple of years, it's been common to have both the variable speed pump and the mixing valve in the design. And I would say a number of years ago, it was, let's say maybe talking 10 years ago, then the common design was actually a mixing valve with the boiler loop pump, but no variable speed pump in the system. So just a mixing valve right here.
Okay.
So there's three different designs typically out there.
Thanks, Ron.
Okay. So the of course, you release boiler, that means release it on automatic. So you'd want this on yes. The next line down, release high speed. Now this is, normally on the systems I work with, I get rid of that line because basically high speed, basically years ago, there was not variable speed drives. So that means it's yeah, VFD, variable speed drive, that can speed up and slow down a pump. Basically, they were expensive years ago. So basically the customers or the boiler manufacturers would put a 2-speed fan on it. So it'd be a high speed and a low speed fan on it. And basically that's where this line came in. So there'd be a 2-speed fan on most of the boilers. But the last 10, 15 years, the variable speed drives have been come down in a reasonable price. So basically everybody's gone to that. So this line is not used anymore. So there's no new boilers with that on there. So basically what I do is I usually hide that line, release high speed, save that, and get rid of that line off the page because it's not being used. And you also see sometimes on your boiler supply, when it's running, it'll say on, off, but it'll say low speed. So there's no more high speed. Basically, low speed is on and high speed is, there's no 2-speed fans anymore. So that's where that, if you're seeing that on your controls, probably if I go back to this. Oh, it's not shown in this strap. Okay, but okay, go back to here again. Okay, so basically the boiler is running. And this pump is running the speeding up and slowing down to get out the 90 degrees out of the boiler. So then the question is, what is actually running the boiler for capacity? So we have a page. I'll come back to this in a minute. So we have some lines here, and typically CO2 on so this is the CO2 is going to get a kilowatt rating in here, and your boiler is going to, so this example, this boiler is a 5,000 kilowatts. So typical, and a lot of boilers nowadays are larger than that, 6,000, and the big customers have like 10,000 kilowatts, 12,000 kilowatts. But so 5,000 is a typical smaller boiler nowadays, and for the vegetable greenhouses, I would say. And so basically the boiler can vary in capacity from 0 to 100%. So at the lowest flame rate, it's going to give about 800 kilowatts, and at highest flame rate, it's going to give about 5,000 kilowatts. And here, so basically what we get a CO2 demand from the greenhouse, that the CO2 is dropping below the set point. So basically it'll come on and put a kilowatt here number to run the boiler. And if you make it aggressive enough, it'll run the boiler at full speed even if you want. Then we have forest storage. And let me see, we have a revert. There's some lines And excuse me for a second, I'm just going to go to this terminal mode because I can bring up all the lines here. So here we have a line called line 9, reserve capacity. The reserve capacity is basically the calculation of heat that for that buffer tank. So if you say I want 40% of heat in the buffer tank, and if it drops below that, or it thinks with the outside temperatures and the heat demand in the greenhouse, it's going to drop below that, then it'll put a kilowatt here to run that boiler for reserve capacity. Greenhouse capacity, like I was saying, that the buffer tank supplies the heat to the greenhouse, and the boiler heats the buffer tank. So basically the greenhouse capacity should always be 0. The only time you get a greenhouse capacity here is if your buffer tank goes cold. So we have this drawing here. So this temperature has a temperature reading here. So let's say the greenhouse here gets really cold, and the greenhouse wants 90 degrees. And for some reason, there's something wrong with the buffer tank only got filled up to 85 degrees. So this is going to be filling up 85 degrees here, but the greenhouse wants 90 degrees Celsius. Then what it's actually going to do is it's going to turn the boiler on to help out. Even though the tank might be 100% full of heat, but it might be full of 85 degrees. If that temperature is not hot enough here to supply that greenhouse on the manifold, then it's going to start up a boiler to help out that buffer tank. So that's a good. So it's good in one way that you get enough heat into your greenhouse. The bad thing is, of course, your boiler is going to be running in the evening to supply heat to the greenhouse, and you're not going to be getting any emptying of your buffer tank. So you won't have enough room for the next morning for CO2 if your buffer tank doesn't empty out. So this is the boiler can start up for greenhouse capacity, which we don't want typically. It starts at CO2. That's typically what we want. And if we have a buffer tank, we have the desired heating capacity. So basically, if that temperature, like I was saying at night, if that temperature in that boiler drops below 70, then it says I'm going to need to kick on. So how does it do that? It basically puts a little bit of heating capacity in line 3 here, internal capacity. Internally, it's getting too cold. It's below the 70. They'll put some kilowatts on the boiler there, put it into this line 11, and it'll start the boiler up to at a certain number of kilowatts to heat back up to 70 degrees, or plus the offset, like talked about. Forced storage. The forced storage is a whole procedure that people can do. And basically what some people do to say that, let's say you have a cloudy day, so you don't have a lot of CO2 demand in the greenhouse. So basically your boiler is not running at very full speed to fill up the buffer tank. So the buffer tank, drops down to say the spring and the fall, drops down to its 20% minimum. And then its boiler is hardly running that day because it only fills up to 40%. So now you're going into the night with the tank only 40% full, and you have a cooler night coming up. So what customers will do is they'll use a forced storage. So they'll say, I want to fill that buffer tank during my period one being back to our 300 page, our day period. So during the day, even if my CO2 is not calling for it because I've reached my CO2, then that boiler will still run at 5,000 kilowatts. So basically it's full speed. Maybe we can make it a little bit smaller, make it 3,000 kilowatts. So basically we'll get a setting here to say, if that buffer tank is not filling up to its 100%, it'll start running up to 3,000 kilowatts to try to force that tank, a forced storage, to fill that tank up. So there's a line here, release storage. So that was released forced storage. There should be maybe another word in there, but I think it starts getting tight in the space. But if you put this to no, that forced storage will not work. If you put this to yes, that forward storage can work, but you still have to have some settings in on the forward storage page, on this page put in here. So basically you're forcing that tank to fill up throughout the day. And that's what the nice thing about that ramp, as someone pointed out, asked about the ramp here, is that at least if you're, as it goes throughout the day, and let's say maybe it's sunny in the morning and your CO2 is filling up the tank, but in the afternoon it gets cloudy, then it still will, the forced storage will go ahead and fill that tank up during the rest of the afternoon. So your tank is full for into the evening. So you got enough heat for the whole evening from the tank. So on this page, we went through most of the settings except for this line here. And basically what that line is, so the boilers have a CO2 condenser on them. A condenser that, so it's basically the exhaust gas comes out of the boiler and it cools. So the exhaust comes out of the boiler and it comes into a condenser here, which cools the air. And then it goes into this fan, and then this fan, after this fan, there's usually a PVC pipe that blows out into the greenhouse. So the PVC pipe can't have higher than about 60 degrees Celsius air. So basically that condenser has to cool that off. So basically that condenser gets too hot of water going through it. Basically that buffer tank, so what happens is that condenser is being cooled by this return water from the buffer tank. So as this tank is being filled up with 90, the water coming out of the bottom of the tank here of that 40, in this case, 42 at the bottom here, that 42, 46 here is cooling off that condenser. So if this water 46 gets too hot, that 46, if this gets up to 60, 70 degrees, that condenser is going to get too hot and it's going to trip and say it's too hot. My water temperature is too hot to my condenser, my CO2 air is going to get too hot and it trips out and gives you an alarm. So basically what I like to do is we like to stop it before that happens. And how we stop that is by looking at the bottom two sensors of the buffer tank. So this example has two sensors, 9 and 10, that are called the bottom of the buffer tank. So number 1 is the top of the tank, and number 10 is the bottom of the tank. So as that sensor gets above 70 degrees, if both those sensors get above 70 degrees, then it'll show the two sensors here. Then it'll shut the boiler off, and it'll actually change to a thing here called cooling status. Oh no, that's right. Right, a new line pops up. It says cooling water. Basically, it says that the water's the cool water, cold being 42. That's normally 46 coming in the back of the boiler is too cold, too warm, and it can't cool the boiler. And then you're going to get the boiler's going to shut off. Then what happens is typically the greenhouse will the boiler will shut off to close this isolation valve. Then the greenhouse will use heat, and the cold water coming back from the greenhouse, let's say it's 40, 45 degrees coming back, will fill up the bottom of the buffer tank. And as those sensors get above or cool down, get below 60, then it'll come out of cooling water. It's not available, and then it'll start up and run the boiler again. So it's just a way to stop the boiler because it doesn't have enough cooling water to cool the boiler off to run it before it actually trips an alarm for the tank. No, sorry, not the tank, for the condenser, for the CO2 condenser. So in here, so these settings, once they're set up, I think you really don't need to change these settings. The only thing is, of course, is be aware of it, because if the buffer tank gets too hot at the bottom of the tank, the boiler's gonna shut off. So you're aware that this is happening. And so yeah, you can always put these numbers up higher and the boiler can run again, but then you risk that it runs into an alarm that your boiler will shut off anyways because the condenser is too hot. So under flow influences here, there's a few things to make settings for yourself. So the one I see customers do is the CO2 here. So let's say this is a 5,000 kilowatt boiler. So they'll allow it to run 5,000 kilowatts for CO2. But maybe their greenhouse is, their boilers are larger than than what the greenhouse needs for CO2. So then they might say, okay, I only need this boiler to run 3,000 kilowatts all day long to get enough CO2. And then also, there's another thing to consider is how big the fans are. So in that picture I had here, these fans, the CO2 fans that are sucking off here, if these CO2 fans are smaller than the capacity of what the CO2 of the exhaust of that boiler, let's say that boiler has so many, and I'm sure the specs can be found, or you can actually just watch the exhaust of the boiler when your boiler is running full speed and your CO2 fans are on. So basically, if you have exhaust coming out of the boiler while your CO2 fans are on, then you know you're wasting, your boiler's running too hard. You're wasting basically CO2 out in the atmosphere. So then you can actually bring your throttle of that boiler down. On this line here and say, okay, my boiler, I'm not going to let it run more than 3,000 or 4,000 kilowatts because I know if my CO2 fan can't pull enough exhaust air away from that boiler. So the settings up here, basically the lines 1 through 4. No, typically you wouldn't touch these lines because they would, once they're set up by the dealer, then they should be working fine. So you shouldn't touch those lines. So this is the only basic one that customers are usually touching. CO2 production high speed. Again, that's one of these lines that are those 2-speed fans we used to have, so we can actually get rid of that. And then we have CO2 ongoing time. So sometimes if your boiler is running for CO2 and your CO2 satisfies in the greenhouse, then it says, oh, my CO2 is fine. If the CO2 goes away and then the boiler shuts off, but then 3 minutes later, the CO2 drops, or the plants are using the CO2. So the CO2 measurement drops in the greenhouse, and then it tells the boiler to go back on and off. So basically, you don't want to prevent the boiler from going on and off. Then you can make a time delay in here to keep that that boiler running for a number of minutes after the demand has gone away. Normally we just leave this one at 0 because normally that boiler should not go to max temperature. If it goes to max temperature, that usually means there's something else wrong, like the boiler pump is not working properly or something like that. Here we have gas consumption. So on the versions, if you have an older version, you didn't have these lines. The newer versions have these lines. And basically, by default, normally they're set to no. So you can put this to yes. If you put this to yes, and this number is at 0, that boiler will shut off immediately because you're allowing it to have 0 kilowatts of gas. So basically, as soon as you put that to yes, make sure you put a setting in here right away, or your boiler is off already. Otherwise, it'll turn your boiler off. So basically, we have a way to, if you're under a gas contract or you have some, if you know your boiler is double the capacity of what you need, or maybe what I've seen a couple times is that this pump here is a little bit undersized. So every time this boiler goes to this highest flame, these boilers overheat a little bit. So then basically what I've seen people do is put a number in here to limit the boiler from running to full capacity. Yeah, basically this is a newer setting the last few years that's been in there. It wasn't there a number of years ago. So this is per boiler. So boiler 1 has this, boiler 2 has this, and boiler 3 has this. So each one of these boilers will have that line to limit how much gas you're allowed to use per boiler. On top of that, there's a page, I304, under gas distribution here, maximum. Here you can actually, for all the boilers, you can say how much cubic meters of gas per hour that you're allowed to use. So this is an override for all the boilers. So the other page I was just showing you was per boiler, and this is for a maximum. And this one, of course, is in cubic meters of gas, or the one I was just showing you was in kilowatts. So that one in kilowatts, you'd have to, if you want to convert that, you'd have to convert that to kilograms, or sorry, cubic meters of gas to see that amount. But if you are under, again, if you're under a gas contract, then you can actually put a number of cubic meters of gas in here. There's not that many people using this, but I have seen sometimes people that have gas contracts that say that they're on an interrupters rate, which means that not most of the year they're allowed to use as much gas as they want, as they need. And then get a cold spell of maybe minus 15 degrees, minus 20 degrees Celsius. And then the gas company will come to them and say, nope, you're got to shut off completely out of gas, or no, you're only allowed to use, 200 cubic meters an hour of gas. So you could actually go here then and say, here, 200 cubic meters of gas. And then your boilers would run up to 200 cubic meters of gas. And then, of course, but that time, most of the time, what people are doing, if they're on interrupters rate, say they'll leave one boiler on gas and the other boiler on oil. They have to switch over to oil to create their heat demand, to get their heat demands they need. So the ore storage we talked about a little bit about, and return control. Basically, the return control we don't use, because basically return control is is something that if the return gets too cold, but basically there you need typically what we do though is we close the mixing valves in the greenhouse if the return gets too cold, and we don't use this return control here. There is condenser control settings, but again, most of those times the condensers, basically there's no control on them. Basically there's a pump that there's a condenser. A condenser then, of course, it cools the exhaust gases. So the condenser cools the exhaust gases, and there's just a pump that pumps the water through there. So there's no valves, there's nothing to control there. Every time the boiler turns on, that pump gets turned on, and it pumps the water through that. So there's really nothing to control, but sometimes people will put temperature sensors on that condenser to see what it's actually, how hot it's getting, and then we can add it to that control there. We have the overview page that we were looking at. So we have the calculated boiler temperature. So the calculated boiler temperature, so even if the boiler is running, just going to take a slug of my coffee here. So even if the boiler is running for CO2, the calculated boiler temperatures typically would be, if there would be normally during the day, so there's probably not a lot of heat demand. So there'd probably be the calculated boiler temperature would actually be at 70. But so that means the boiler is actually running for kilowatts, and it's not running for this minimum calculated water temperature. So it's running for the kilowatts. And like I said before, the pump is controlling the temperature. It's slowing down and speeding up to get the temperature out of the boiler at 90 Celsius. So how do we do that? And there's a page on the fill circuit. So this, if our boiler max temperature is 96, and we have a page here called control range fill temperature. So we set this to 6 degrees. What happens then is that max temperature of 96 minus 6 degrees is 90 degrees. So basically what will happen then is we're telling that fill circuit, the pump, to see it's got a fill temperature. We want to fill the temperature 6 degrees less than the maximum. And then that pump is going to speed up and slow down to try to get the 90 degrees coming out of the boiler. So if you don't get 90 degrees coming out of the boiler, so it'll say calculate at 70, but you're actually targeting 90 here. So if you don't get 90 degrees out of the boiler, if it's going up and down, then there's probably something wrong with the, not quite often, not very often, it's actually a problem with the boiler settings. It's actually more often a problem with the settings for running the pump. So that's basically the dealer or Priva has to help out then with the settings to fine tune that to make that pump run smoother, or in the case if you have a mixing valve, to make the mixing valve run smoother to keep that 90 degrees coming out of the boiler. So then so we have we convert the kilowatts. So you got the kilowatt demand. So you got between 800 and 5,000 kilowatts that this boiler has capacity of. So if the flame is at lowest flame, we're going to say a valve position of 0%, and it's going to be giving out 800 kilowatts. And then when it's at full flame, so it's at 5,000 kilowatts, it's going to be showing 100% capacity here, and it's going to be showing 5,000 kilowatts. And then it's going to adjust between these two. So let's say if it's at 50%, then it's going to be halfway between this. So it's roughly around 3,000, let's say 2,900 kilowatts, halfway between these two numbers. So if this is 2,900 kilowatts, should say about 50% valve capacity. So it says valve. Basically, that means the gas valve. So these boilers have typically a gas valve that opens and closes, and then it's got a variable speed fan that blows the air through the boiler and emits a gas and air mixture that burns to, and then they usually have like an oxygen sensor that fine tunes that. So basically, it's a feedback from the boiler panel that we get that 0 to 100% flame rate of the boiler, which is showing here on this screen here. And again, there's no high speed, so typically we can get rid of that line too. And get rid of it. So there's no high speed there, just a low speed, or just it's a 1 speed. Variable speed fan, variable gas valve, but 1 speed, yeah, not a 2-speed fan like it was in the olden days. And then we have a button for the CO2 control. So it just tells you what the CO2 is running, how many kilograms of CO2. So basically we convert your CO2 settings. So you make your CO2 settings you want, how many ppm. So if it's sunny outside at 400 watts, you get 1,000 ppm of CO2. Then we have a link on this page to say, if you're 200 ppm below set point, we're going to give you 500 kilograms of CO2 per hectare per hour. So the 500 kilograms of CO2, and then we know that every cubic meter of gas is 1.8 kilograms of CO2. So we can convert that, and we know natural gas is so much capacity of kilowatts of heat out of that. So we can convert in this internally in the computer, then we convert that that kilograms to cubic meters of gas, and then cubic meters of gas to kilowatts. Basically, you have a reading here. So internally we put how many square hectares, square meters in the greenhouse. So that converts to square hectares in there. Then on this page, you'll collect all the different CO2 pages, because you might have different CO2 pages for different areas. And this will be the number of kilograms of CO2 you want for the whole greenhouse. And then it tells then certain boilers to turn on, or in a certain case that if your boilers are too hot, maybe even turn your liquid CO2 on if you need to, if you have liquid CO2. So that's how it calculates the CO2. So the M320 is our buffer tank. And then, so buffer tank, we have our 10 sensors we were talking about. And then here you can see whether it's filling or it's emptying. If it's full, so if all the sensors are reading 90 degrees, it's going to say full. If it's all the sensors are reading 0, it's empty. And this is a demo system right now. That's why it's a little bit confused of what it's doing. And then you get this desired. So this desired will be ramp up, of course, up to 100% during the day. And there's one setting I didn't talk about, and that's this setting right here at the top of this page. So correction start filling empty. So normally we put this one to yes, and we put this one to no. And what happens here is that typically you would want to ideally, fill up your buffer tank to 100% at the end of the day, and then at nighttime the boiler shut off and your tank uses up all the heat, and you get down to 20% in the morning. So your CO2 starts, you ramp up from 20% to 100%. But what happens sometimes is you get a warm night, so it doesn't actually ramp down to, doesn't actually use up all the heat. So you don't actually get down to 20%. You actually you only get down to 40%. So basically what's going to happen then is if it actually starts at 20%, that means that the first couple hours in the morning, as it ramps from 20 to 40, it's going to say my tank is too full, and it's not going to let the boiler run very hard for CO2. So what we do then is we put this to yes, and we change the ramping. We change the starting point. There's change the start point. So instead of starting at 20%, it starts at the where you left off at this time in the morning. So if you only empty to 40%, then the ramp will start at 40% and ramp from 40% up to 100% for the end of the day. So you get even CO2, even filling of your buffer tank for the whole day. So you see that I made a pretty simple, just 2 periods. So you can see sometimes though people will make multiple periods here. And what they'll do is they'll say, okay, my plant's in the morning. I want to use a lot of CO2 in the morning. And they put some reasonable times in here. So from the morning till 1 p.m., I want to fill my tank up to 70%. And then the last bit of the day, I can fill from 70% to 100%. And that basically allows a little bit more room in the morning hours to let the boiler a little bit more CO2 in the morning. Or you could do the opposite and say only fill up to 40% by this time and give you lots of space in the afternoon to run it hard. So basically there's something more of a grower setting to say what time of the day would he, if his buffer tank is not large enough to run his boilers hard all day long, so that he can fill up his buffer tank a little bit more first thing in the morning or later in the afternoon or middle of the afternoon, or make multiple periods here to stage filling up his buffer tank. So so we're talking about, so these settings here on I320, normally you'd want your boiler buffer running all the time, so you'd always leave this on yes. And these settings are just that if the supply return of the tanks get to the same setting, well, there's no sense emptying the tank or filling the tank at that point. There is a frost protection on the tank, so if any sensor gets below 1 Celsius, it gives you an alarm. So that means that, obviously something has drastically gone wrong, because basically, if the tank is completely full, it's all 90, but even if it's empty, and if I go to that other shot here of a screenshot, basically these sensors are all the typically cold sensors, but you can see that it's cold is even 42 Celsius, which is, of course, around 105 110 Fahrenheit. So that means that cold is typically still a very warm temperature. So no, there's no way that one of these sensors should get down to 1 degree. That means something's would have to be drastically wrong or be a bad sensor. So the next tab here. So this one is kind of a nice play that customers can play with. So basically all the sensors get to 90 degrees, then the buffer tank is considered full. So basically, if by chance you say in the summertime, I want to not fill my buffer tank with 90, I want to fill it with 85, then you could actually go to here and say, bring this down by 5 degrees, 91. So that 91, so this offset here of 6 degrees is still there. So that means 91 minus 6 is 85. So that means you're going to fill your buffer tank with 85. But you're still, the calculation is that all the sensors have to read 90 before it reads 100% full. So then you could go to this page and say 85 degrees. When they all read 85 degrees, then I consider it 100% full of heat. So just that's how it calculates then. It's a pretty simple setting. And setting's been here for maybe 5 or 7 years in the system. And before that, there was an internal setting. So that would be something that we'd have to help you with if you have an older system. So what determines when the tank is empty? Because sometimes the return temperature is, if it's not a cold night, then maybe the return from the greenhouse is like 38 degrees or so, 35 degrees. And maybe a very cold night, the return temperature is 45 degrees or so into the tank. So basically, the return temperature is coming into the tank is going to be dependent on what the return is from the greenhouse. So basically what we do is we look at these return temperatures and we calculate the last 2 sensors in the tank. We look at them, and if they are whatever temperature they are, that's going to be our empty temperatures. So basically that's going to be 42, 43. When all these sensors read 42, 43, that's going to be our empty. But then the next time it fills up and empties again, if these things are going to be at 46, then they all have to get to 46 for that thing to be empty. And basically, we're only looking at these 2 sensors when the tank is more than or less than 50% full of heat, because we don't want this. You can see that the top sensors are 89, 88, so they're all pretty close, but then you start getting some mixed temperatures here, couple mixed temperature sensors. So we basically always want to have this sensor tank at least 50% empty before we start looking at this. Otherwise, we start looking at sensors that are got a little bit of mixing of water. Because say something about that for a minute is basically as that 90 degree comes in and it's pushing that the coldish water out. Basically, these tanks layer really well. So basically, you can see that we get 90. All these temperatures are within a couple of degrees, and then all of a sudden it drops from 83 to 43, and these ones are all within a degree. So this is pretty typical of tanks that they should layer very well. If it's not layering very well, then there's something typically wrong in your tank that it's not doing this. So these measurements here also, if somebody's played around with these points, that means that this overrides the sensors that are reading, the return sensors that are reading here in the back, coming in the bottom of the tank. So basically, if you put these by a mistake, if you put this to 70 and 70, then it thinks that it needs 70 degrees in the bottom of the tank to always be, and when all the sensors are 70, it's cold. So basically, it's a range of that of the computer to say sometime those sensors between those temperatures are going to be at the bottom of the tank, going to be determine our empty percentage. And this page we looked at already. So this again is our filling circuit, our 6 degrees below our maximum boiler temperature. And that one. Okay, so I did start at the beginning that the boilers were going to be talking about that they can fill on greenhouse demand, which we don't want. We want it to fill because of CO2 or forced storage or reserve capacity. So what is reserve capacity? Reserve capacity is basically we look at, so this is standardly how we set up systems. You can set them up differently, but standardly we put it out at yesterday and a strategy. So basically what it's doing is looking at the trend of weather, so the last 24 hours of weather, and it's looking at your heating set points, and it's calculating out per hour how much heat demand you need in the greenhouse. And then it figures out from there how full it should fill your buffer tank. So basically, if you have a 20% minimum, then basically you'll have about 20% in here all the way down. And then if it's colder outside, it's going to put a reserve capacity in here. So in the summertime, these will be all zero because it doesn't need much heat. But in the so wintertime, it'll start calculating numbers in here in a percentage in here that it needs to fill the tank to. And for each hour, this will have a different number. So it all depends on what you have in here. So as long as you have on a standard system we set up, I set it up like this, and you're going to get a number in here. So what's going to happen is you're going to fill your tank during the day for CO2. Then it's going to be full enough. So it's going to say, oh, I want my tank. It thinks it needs roughly around, say maybe 70, 60% all night long in that tank because of my heat demand in the greenhouse. But I filled up my tank now for up to say 80%, 90% of heat. So then the boiler won't run all night long. And the next morning it'll come along and say, oh, it's dropping down to below 60%. And I need 60% because in the morning it's going to be cold. So now it'll start running the boiler, say at 3 in the morning to keep that boiler at the buffer tank at 60% full of heat till it comes along to CO2, and then it'll start running again for CO2 and reserve capacity to make sure there's enough heat in the tank. So that's reserve capacity. That's looking at then your last 24 hours of your weather and it's looking at the strategy of your settings. So you can put this to CO2, but what CO2 does, it prioritizes the buffer over for CO2, which means that it'll bring all these numbers down lower, and it doesn't care about if it thinks it can get that tank down to 0%, it'll actually run that tank down to almost 0%, which is kind of scary in our weather in the north here in Canada, because you could actually then empty your tank out. And then, of course, if all of a sudden you have a cold front come through, then you can't keep up in temperature. So that is something so we always recommend to do something like this. Yesterday and strategy is a pretty good starting point for all greenhouses. So so what happens sometimes is we get a cold front coming through. So we have, so of course, it's looking at the last 24 hours of weather, and all of a sudden the cold front starts coming through, and they say, oh, I want to fill up my tank a little bit. So there's a number of ways to do that. We have that forced fill we talked about earlier. You could just say here, I want to put so many kilowatts in, and I want to fill my tank 100% fuller than I want to keep it. And put that on for every period that's active. And then I'll just run that boiler at this many kilowatts to fill that tank, which is a nice way to run it. And then there's another way to do it. And this is a setting you have to make per boiler. In here, you could say minimum reserve capacity. So let's say I have 3 boilers of 5,000 kilowatts. So if I type in 15,000 kilowatts here, that'll tell all my boilers to run at full speed, 5,000 kilowatts each, times 3 for 15,000 kilowatts. So then I'll just, I see a cold front coming through. I want my boilers to run flat out just to try to fill up that tank to heat that system up. But I would say, of course, that's, don't want to forget about this setting, because then it's going to run them flat out all the time. So what you could do is say just a temporary setting. 15,000 kilowatts till, let's see, till 9 o'clock tomorrow morning. So it's going to do that till 9 o'clock tomorrow morning, and hopefully the sun comes out and and it's we can catch up with our tank at that time. So this is just something that can a temporary thing that you would use to if you see a cold front coming through. This setting here is adjustment of their heat reserve. So basically, this heat reserve has 15,000 in it now, since I typed in 15,000 here. Go back and look, so you can see that the reserve capacity of 15,000 all the way through. So to get temporary settings, if you right click on it and go to advanced control, then the thing here, you use temporary setting. There's two ways to get there. There's a little arrow on the side there. You can click on that. You can click on that, or you can right click and go to advanced control, and you get that. You can say use temporary settings, type in what you want, and then pick some preset times or select whatever time you want. So let's say 1800 hours or 1600 hours, and you can say I want this for. In this case, I have two heat managements, so I can select it for both of them, or only select it for this one, and then copy that, and then it would set that setting till. We can go back and look at it. So till 1600 hours, so 4 p.m. this afternoon, this would be happening. So this setting here is adjustment heat reserve. So basically, if this is something good if you see a cold front or heat or a warm front coming through. So basically, your boilers you see a warm front coming, and all your boilers are running like crazy because you have a higher heat reserve because it's been very cold. So what you can do here is you can say, okay, for the next, I want to put minus 50% for the next few hours. So I'm going to subtract 50% of my heat reserve. So all these numbers then will drop by 50%. To not fill the tank so much because you see a warm front coming through. This overrides, the minimum will override this adjustment. So, but you can do this if you see a warm front or a cold front coming through. Vice versa, you can go here and say, okay, I see a cold front coming through. So instead of using the minimum that I used here, you could say, okay, just fill up my buffer tank 50% more for the next, well, I can use the same example I had earlier. So till 9 o'clock in the morning. Well, till 9 o'clock in the morning, my heat reserve is going to be 50% higher to try to keep that tank full for the next number of hours.
Ron?
Yes?
We just a couple questions here. So the first one, and I think you showed that, but how do you, the question is, how do you get the option for temporary setting there? Where did you click on?
Yeah, so if you click on the little arrow on the side, it comes up. Or if you right click and go to advanced control, it comes up there. You click on it.
Okay, thank you. And another question that just came up is, what temps should you consider for a cold front?
Let's say you're running around like 0 degrees Celsius or something like that, and all of a sudden you see that tomorrow, like midnight or something, you got some, or like let's say later that afternoon or something, you see that like minus 15 degrees is going to come through. Well, that's going to be a big temperature difference. So yeah, then I would say that's a cold front. So big as a 15-degree temperature difference, or the vice versa. You have maybe it's minus 10 for the last couple of days, and all of a sudden you get, the forecast for this evening, you're getting a warm front coming through, and it's going to be plus 5 degrees. So a 15-degree difference or so. Yeah, a 5-degree difference, 10-degree difference is probably not a problem for the buffer tank. But when you start getting 15 Celsius difference, then that's going to be a big difference for the heat demand.
Thanks, Ron.
So then we have this page here. This is an overview page of all the boilers. So then you have your, so you can see that the greenhouse demand. So basically what we want to see here is we want to see the greenhouse demand. This is normal, like, well, this is pretty high temperature here for our demo. And we get 1,000 kilowatts demand in the greenhouse. So basically this line 3 here. This 1,000 kilowatt should also be in here. So it's taking the heat from the tank. So like I was explaining that the buffer tank, the greenhouse should be calculating and taking the heat from the tank, and then the boiler should be looking at the level of the tank and then filling for CO2, or they should be running for CO2 or to fill up the buffer tank. So then you have
Ron, just before you continue, just to get back to the question about the option for temporary settings, did it show temporary settings in there, or is that maybe an older version? Because the question or the follow-up question was try to advance control, but it does not show temporary change. Maybe an older version?
Probably an older version then. Yeah. This temporary setting has been around for like 4 years. So if you want, on your Priva Office, if you go to Help and About, they'll say the version number here. So this is the newest version, 9.7. So I'm not sure what version the temporary settings came in, but probably if you have version 8, then possibly like 8.4 or something like that, then possibly you don't have that. So you have to update to an older version or Priva Office.
Okay, thank you.
So M300 is a nice page. You can see, which boilers are running. And then, like I was showing you these pages. So these are geographical layout pages that we make. So basically every new job that we do, we'll make 3 pages like this, 1 page for the boiler room, 1 page for the irrigation room, and 1 page for a layout of the whole greenhouse. So that's, so 1 page like that for and 1 page, I'm not sure if this is the irrigation room, that's the irrigation room. So basically, if you want these pages made, we can make them for you. So mostly it's just the Priva guys that are making this, because we have it's a tool that we use under Microsoft Visio to make these pages. But you can, it's all the same data that you can see on the other pages, except it brings it into a visual format with graphical slider bars and stuff. So here you can see that if the boiler is running for, of course, back to this line here. So this emptying line should always be equal to this. And if that isn't like that, then there's typically something wrong, that you're asking for too much heat in the greenhouse, with the setting wrong, or that the temperature sensor coming out of the buffer tank, this temperature sensor here is not reading right, or your buffer tank didn't fill hot enough or something like that. So there's typically, if these numbers are not, this 1046 is not in here, there's typically something wrong set up. And then, so that means that if this number is here, then this greenhouse demand should not be here. So this should always be 0. That's typical. Then when your boiler starts out for CO2, you get a CO2 kilowatts here. If you're using the forced storage to make sure your tank is filled up by the end of the day, then you got a number in here. If it's dropping below your minimum temperature in the boiler, then you'll get a heating capacity there to get back up to that 70-degree minimum. And then this is actually what it's running on right here. Typically that's the main, so this is for CHPs. There's not that many customers with CHPs, so I wasn't going to talk about that too much. And heat exchangers, there's hardly anybody with heat exchangers. Typical, the heat exchangers that are, say, heat coming from another heat company, that's so that's a heat capacity that's going from another like I think they have typical in Holland. Sometimes they have some of those places where there's a generating company beside them that's supplying them some heat. So they give them there's a heat exchanger that they take heat from. So that's not typical, very typical in North America.
Ron, just a quick question here on M300. What is row 1? It says alternative strategy active.
M300?
Yes.
So you have these alternatives conditions you can turn on. Alternative. So you can turn these on, and you can say what. Most of the time this is not used, but what we can do is we can say that boiler There's a couple different pages for this, but you can say that boiler 1, your standard strategy, that boiler 1 is first priority sequence number. Boiler 2 is second priority. Boiler 3 is third priority. But then if you turn on your alternate distribution, you can change your priority system around. You can change that your boiler 3 is the third priority. So what you could actually do is say Monday, Tuesday, Wednesday, you have standards. So the boiler 1, 2, 3 runs like this. But then on Wednesday through Sunday, the boilers work the opposite way. So priority boiler number 1 is like that. But talking about that for a second, basically, if each of your boilers is identical and they each have a condenser on them, that means the efficiency of them is the same. So typically that means that the lower, kind of the consensus is the lower you run your boiler flame rate, the lower your exhaust gases are, which means that you're more efficient your boiler runs. So typically it's thought to be that it's more efficient to run 2 boilers at 50% than 1 boiler at 100%. So if your boilers are all identical, then I would say then the typical thing is you run them all, if you run them all, if they're all identical, you run them all at the same priority, the same sequence number. But if you have 2 boilers that are, let's say newer boilers and have condensers, and some boilers that don't have condensers on them, then you'd make a different priority system for them.
Okay. Thank you.
So this is a page that people don't look at very often, and sometimes it's nice to look at. And it shows you, so when it starts up the pumps, and that's this pump here, the filling pump, then a new line will come up here and it'll say calculated shunt temperature. And then you'll say your return temperature. So this is the return from the greenhouse or from the buffer tank. And then this will be a calculated temperature for the back of the boiler. And then the shunt mix temperature. So that means the temperature sensor that's sitting right here. So basically you have this temperature water being pumped around this 90 Celsius coming around, and then you have the return from the tank, let's say that's 40. And then this is a mix of the 90 and the 40. So it's a shunt mix temperature of here. And basically that's going to be going into the back of the boiler then at that point. So this is kind of a little bit more to watch what's going on then, that the computer is calculating the number. So if you have a geo page, we have there's a calculated and measured here. So quite often we put those numbers on this page so you can see what's happening. So how the computer actually calculates out this is it wants 90 degrees out here. So to get 90 degrees out, it says, so your burner is running at half flame, say 50% flame. So at 50% flame, we roughly need maybe, we want 90 out. So we got to say we want 80 degrees in the back of the boiler. So to get 80 degrees out, we speed up and slow down this pump to get 80 to mix with this, mixing the 40 coming here with the 90 coming around here to get the 80 degrees back here. And then at that point, you should get 90 out here. But if we start getting 91 out here, then we start calculating this down to say 79. And to get 79, then we have to speed up this pump a bit to get a little more cold water to get that temperature down to 79 to get that to be 90 coming out. So that's how this calculation works to speed up and slow down this pump.
Ron, I got another question for you. And this one might be a little bit broad because, of course, with the Canadian winters, basically asking what is the average energy demand per hectare for a greenhouse in Canada in the winter?
I don't know that off the top of my head. Yeah, no.
Okay. No, I figured it was a broad question, but nonetheless, I thought I'd try. Thanks.
Yeah, it's kind of like there's probably I'm sure there's the greenhouse guys have designed it, but then they design it typically on, of course, most guys have glass. So whether you have glass or plastic, or whether you have one curtain or two curtains, and what type of crop you have, because to say strawberries has less heat demand than tomatoes, and so yeah, so it's a pretty broad question. Yeah.
Okay. Yeah, there are obviously a lot of variables. So
Yeah.
it's probably something that they should be maybe discussing with their consultant as well, right?
Yeah. So you can
Okay.
look at that number. You can look at this number here, the kilowatt demand from the greenhouse, and you can graph that number, and you can look at that over 24 hours, and then you can divide that number by the hectares of your greenhouse, and you can calculate it out. So it's so this one here right now, the greenhouse demand is 26,000 kilowatts. And and I know this greenhouse where I took the screen capture from is about is around 30 hectares. So you got about right now at that point you have around 100 kilowatts a hectare for that example. Okay, so the M250 for the CO2, I think we kind of went over this kind of fast. So there's so we can have CO2. There's active. So most customers are using active, and then there's active, and then there's passive, and then there's both. So basically, if you put on passive, you'll lose all these settings. You only get a maximum, because passive means only don't turn the boiler on. Only run the boiler for CO2 if it's already running. So let's say it's already running to fill the buffer tank for reserve. So really, this doesn't make any sense to do passive. So people do active typically. So basically, when the plants need CO2, it'll actively turn on the boiler, and then which will turn on the CO2 fan and pump the CO2 into the greenhouse to get your ppm set points you want. And then you could do both, which is then it turns on the CO2 for active, so I'll turn the boiler on. But if the boiler is already on in the morning because the buffer tank is very cold and there's a lot of heat demand, then it'll also run the boiler, run the ppm up to a maximum. If it's already on, it's going to run the boiler, keep running the boiler and get the CO2 up to 1,000 ppm. So then I've had some people say, I don't really need that, because basically in the morning, if the plants are just waking up, there's not much light out. If there's only 1,100 watts of light outside, I only need 400 ppm for my plants because not going to take anymore. And as the light goes up, then I'll crank up the ppm up higher to 1,000 ppm. And basically then so I only need active. And then some customers will say, well, no, its boilers are running anyways. Why not crank it up to 1,000 ppm? It doesn't hurt the plants. And so there's different grower mindset on that. The grower mindset, one grower is saying, like, you don't give it extra fertilizer if it's not sunny, if it's not sunny outside, because it's not going to do anything. And yeah, so kind of the same idea is you don't give it extra CO2 if it's not sunny in the morning, because it's not going to do anything. But it's just it's free anyway, so it doesn't. There's no wrong answer there, of course. So I would say most guys are just doing active. So what happens then? Then you get that 250 page where I was at. So if you don't have, so you can set this to active and passive and both. But if you have this set to no, that means the lights are not going to go on. I'm sorry, the lights. The CO2 boiler is not going to, the fan's not going to run because the released passive is not on. So you should actually set this to yes, so that the passive, it's easier to leave this on yes all the time. And then you can, then whatever you set in here, then you can actually, if you do decide to change your mind, then we'll run for passive.
Ron, I got a question here. How do I know how much CO2 or kilograms of CO2 can be produced by my boilers?
The one thing that's, you can usually see it here when it's running. it'll actually be a setting. It'll show here kilograms of CO2 that when it's running, so you can actually see at that point. So if your boiler is running at so many kilowatts, it'll convert it to kilograms of CO2 right here. So in case you're, depending on, basically it's a straight calculation typically of 1.8 kilograms per cubic meter of gas. So it should actually just convert. I don't think anybody's changing those numbers, so there should be a straight conversion here to there. And you can also see it here when you put in a maximum here, but then you'd have to calculate. So if you put this number here to be the same as if you got 5,000 kilowatt boiler, put 5,000 here, then you can actually see that it'll say 5,000 here, and it'll say how many kilograms of CO2 are possible also.
Okay. And theoretically, if they want 9,000 less parts per million of CO2, is that possible to get?
The
the
meters only read the meters only read up to 3,000 ppm. So and typically I think there's a labor safety thing in Ontario that you're not supposed to be over 1,500 ppm for more than so many hours or something like that. It's not safe for employees. So you said 900 or 9,000?
9,000 to kill pests, I guess.
Oh. I guess if you have the greenhouse closed, you have the windows closed, and you keep pumping the CO2 in the plant. There's no plants in there. If there's if it's nighttime and the plants aren't using it, I never had this question before, but I guess if you keep pumping the CO2 in during the nighttime, but yeah, like I said, the meters only go up to 3,000 ppm, so you wouldn't know. The meters just stop. They probably give you. I'm not sure if they give you alarm even, but they probably stop at 3,000 anyways. Get flat line at that point.
Okay. Thanks.
We used to actually sell some meters for research places that go up to 10,000 ppm, but we haven't sold those meters in a long time.
Okay. Thank you.
So then on I250. So if you have liquid CO2, then you'll get a spot on the bottom here that you can also, in this demo, I have to do it this way to bring up the liquid CO2. So basically what happens is, sorry for all the lines on the page here, but so basically you can external CO2 is liquid CO2. So there's a page you can set in how many kilograms of CO2 you expect from your liquid CO2. So in this case, we have typed in that it's 1,000. When the nozzle opens up for liquid, you get 100 kilograms of CO2 per hectare per hour. And so basically on this page then, that's what many customers are doing. They're saying during the day, when I know my buffer tank is going to fill up by the end of the day, so I don't want to use my CO2 during the beginning of the day. My liquid CO2, I'm going to rely on that I'm going to get it. So then my afternoon, I'm going to, if my ppm drops below 450 ppm or so, then I'm going to allow my liquid valves to go on. And then the rest of the time, so only to say the peak of the day, so you make some time periods up here. I got too many lines on this page, sorry about that. So maybe we make 4. So the warmest late part of the day, when my buffer tank is probably getting full, like 1,400 hours. So the last couple hours of the day, then I allow my CO2 to go up, my liquid CO2 to come on, but only if it drops below 450 in the greenhouse, because of course liquid CO2 is expensive and you don't want to use it. But if you have inexpensive CO2, then you can make those numbers a lot higher for different priorities. But typically that's how most people will run it. So I think I went through most of the pages that I was planning on. Was there any other questions come up in the last couple of minutes?
There are a couple that might be interesting here as well. Let me just get to those. Your minimum heat percentage you should have in your heat buffer tank for spring and fall.
Yeah, so that's the one I kind of started off with. So
Yep.
to say that spring and fall, that 20% is a good setting, and
Okay.
summertime like 10%, and then yeah, wintertime is whatever you feel comfortable with. So yeah, if you have some old boilers that sometimes break down, then maybe you may want to make 50% in here. And but yeah, if you're some guys I come to and their tank is like this double the size they need, it's built double the size because they're ready for the next expansion. So then they never go up to 50% because minimum, because they say that's going to be way too much heat for the existing guys. So it all depends on the size of your tank and the quality of your boilers, but you can put different numbers in there. Yeah.
Okay. And another one here, buffer tank, nitrogen versus open. Is one more efficient than the other?
I don't think there's any difference. Just biologically, not that I know of, but just off the top of my head, I would say since nitrogen layer is a more physical thing on top of the, because it was like a bladder, as far as I know. I'm not sure if some of the other guys here know more about the top of the buffer tank, because it's a physical thing, not really a control thing from us. But but typically then the bladder would, you think, would be more insulated than just air on top of it. So you think the bladder would be a little bit more efficient than just the air. So that basically if I see that, the greenhouse builders in Leamington, they're basically building the tanks with no bladder, with just the top is open with air, and then the ones from Holland are typically always putting that bladder with the nitrogen layer in it. Did I
Okay.
answer that question?
Well, let's see if, one second here. Lots of pings going on in the chat. But he says thank you. So if your buffer, another question here, if your buffer percentage fill is set at 40, should the top 4 layers be at the temperature set point, or do they add up to meet the set point?
They should be at the set point. Yeah, right. Typically.
Okay.
So typically the top 4 should be, yeah, if it was running perfectly, the top 4 should be at 90 degrees if you're filling at 90, and then the bottom sensors should all be at the same, roughly at return sensor. But you see that from this example, it's not always going to be perfect. You're going to be, there's going to be usually always a couple sensors that are kind of in between. So you got 42, 43 of the bottom 4, the top are all close to 89. So there's going to be a couple there. So yeah, it's not exact layering in the tank, but yeah, if the top 4 sensors are 90 and the rest of the sensors are returned, then yes, it'll be 40% full of heat.
Okay, thanks, Ron. And beside the obvious reasons, why would a boiler turn on?
So yeah, so that's the 5 things that I kind of went through that time. So basically, greenhouse capacity, which it shouldn't, because that should be coming from the tank. CO2 for storage, nighttime for a minimum temperature to keep the boiler warm from getting condensation, and then of course the reserve capacity that we talked about, that it looks at the last 24 hours and desires the reserve capacity. So those are the 5 reasons typically the boilers are running.
Okay, perfect. I think that covers all the questions. To the audience, if you have any questions, maybe type those in the chat over the next minute or two. And if we don't receive any additional ones, then we will end this session. Of course, this is all available for your review, again, on the Priva Academy. So in about a week, you sign into the Priva Academy, this recording will be available to you, along with all the other live sessions that we've done over the last 6 or 7 months. There's quite a few different topics in there that might be interesting for you. And of course, we'd love to hear from you as well. We'll do a follow-up after the session in the next week or so to ask for some feedback from you on different topics that you might find interesting for you and your team to be to hear about. And of course, if there's enough if there's enough request for that particular topic, then we will work with our technical teams here in North America to put other sessions together. Oh, here we go. Okay. Here we go. If the boiler is off and there's hot water in the buffer, will the pumps in the greenhouse pull from the buffer?
Yes. So typically, if the boiler is off, it should close this valve, and this water level is up. Then this red pipe here is down low. It's always sitting in the water. So basically, when these pumps, the transport pumps run, or the greenhouse, or any pump that's on this manifold, basically then they'll suck the water out of this tank. And these typically then at nighttime, that's what happens. These valves are closed for the boilers, and then all the heat comes out of the tank, and then the return water from the greenhouse goes into the bottom of the tank, replaces the water in the tank. So the water level always stays exactly the same. The only thing that it does change a little bit as the water heats up. Of course, water expands a bit, and as water cools down, it contracts. So you'll get if you got a water level sensor in the tank, you'll see it go up and down about a foot as it gets really cold and it will really get warm. But basically, that red pipe is always sitting in the water, so that water can always be sucked out of that tank. So.
Okay, thanks, Ron. Another question here: how does the blowout strategy work? What does it actually do in the greenhouse?
The blowout.
Oh, one second here. Yeah, how blowout strategy works. What does it actually do in the greenhouse? So
the off take, or you're talking about the off take when the boilers get too cold, or are you talking about the blowing of the CO2?
Well, I'm just waiting for a response. From Bhargav Patel. Let's see here. Okay, blowing out CO2.
Yeah, so basically, the CO2 fans, yeah, they usually put the piping underground. Sometimes it's above ground, but most of the time it's underground, and then it's got all the tubes. Like either they put like for vegetables, basically there's a plastic tube that's around 2 inches in diameter, clear plastic tube, which a bunch of holes in it that they run under the gutters or in the crop, and then that spreads the CO2 out throughout the greenhouse. So whenever the fan turns on, it blows up all those little plastic tubes and blows out the greenhouse throughout the greenhouse. Or in some cases, they have like nozzles behind fans that blow out the CO2 around the different fans in the greenhouse. But most of the time, it's all little plastic tubes in the greenhouse.
Okay, thanks, Ron. Another question here: when the height of the buffer goes down, is refilling manual?
Typically, yes, but there's some customers that have put that have constant leaks. Some large customers that have constant leaks somewhere, and they have automated it, so it's kind of scary. But it's so yeah. But normally that's manual. Yes, usually there's a manual valve that's either it's plumbed in already, or you have to hook up a hose to fill up the water in the system again. And then for the nitrogen system, that's usually a standalone system. That there's usually a control panel that's not tied into Priva that has a control panel on that when it gets low or high, it takes care of that. But that's not part of the Priva controls, or usually we tend to have anything to do with it. Sometimes there is a level sensor or pressure sensor in that tank that the odd customer is wired back to the Priva to show it on the Priva and graph it. But most of the time, those systems are kind of standalone.
Okay, thank you. I don't have any other questions, Ron, that have come through. I think that we can end the session now. And of course, if there are any other questions that you have, or you'd like to discuss something, please reach out to us. Of course, all the contact details, we will follow up with you. You've received emails from us. There are emails in there for both of our offices in the US and Canada. And of course, if you're dialed in today from Mexico, our US or our Mexican office details will also be available available to you. So we will send a follow-up, and if you do have any other questions, then you could reach out to us. So Ron, thank you very much for your time and expertise today. It was very informative, and of course to our audience, we really appreciate your the time that you've spent with us. I know it's been almost 2 hours, so it's a lot of information. But again, it is available on our Priva Academy to download, and that'll be about a week before they have this up and running. We'd like to wish everyone here a Merry Christmas and an enjoyable time this holiday season, and wish you also a Happy New Year. And we look forward to offering new Priva Academy live sessions in 2024. So our new lineup will start most likely in February, and we hope that we'll get some feedback from you as well to come up with some new topics. So thank you again. Happy holidays, and we will see you next year.